Welcome back, users, to lecture number 1, part 3. You can see the slides discussing the advantages of using routers. So we have two main advantages of using routers. First, they don't forward broadcast by default, as we discussed it in the previous part of lecture number 1, that routers break the broadcast domain. So the router do not forward broadcast messages by default, they block it. In addition to this, they can filter the network based on layer 3 network layer information such as an IP address. Okay, so this is the second advantage of using router. Okay, so we can see now functions of a router in any network. We have four main different functions of router. Number one is packet switching. How a router switch packets. Routers, also known as layer 3 switches, use logical addressing IP or IP version 6 for packet switching. Number second, we have packet filtering. A router can also provide packet filtering using access lists. In addition to this, we have inter-network communication. When routers connect two or more networks together and use logical addressing, you then have an inter-network. And in the last, we have path selection. Routers use a routing table, which is essentially a map of the inter-network to make best path selections for getting data to its proper destination and properly forward packets to remote networks. Now we will discuss switches. So we do not use layer 2 switches to create internetworks. For that we use routers because they don't break up broadcast domains by default. They are employed to add functionality to a network, local area network. The main purpose of these switches is to make a LAN works better, to optimize its performance, providing more bandwidth for the local area networks users. These switches don't forward packets to other networks like routers do. Instead, they only switch frames from from one port to another within the switch network. Switches create separate collision domain within a single broadcast domain. Now we will discuss bridges. The term bridging was introduced before routers and switches were implemented, so it is pretty common to hear people referring to switch as bridges. Bridges and switches basically do the same thing, break up collision domain on a local area network. You cannot buy a physical bridge these days, only local area network switches which use bridging techniques. So switches do provide a bridging function, but they do that with greatly enhanced management ability and features. Most bridges had only 2 or 4 ports, which is severely limiting. You would use a bridge in a network to reduce collision within broadcast domains and to increase the number of collision domains in your network. Doing this provides more bandwidth for users. And never forget that using hubs in your Ethernet network can contribute to congestion. Is always plan your network design carefully. Okay, you can see network design. This was also present on the previous slide, but without the colors. It is now with colors. Looking at figure, did you notice that router has the center stage position and connects each physical network together? This is a network segment, this is second network segment, and this is third network segment. See that bridge up at the top of our internetwork shown in figure. It is there to connect the hubs to a router. These two hubs connected to the router, we have used this bridge. The bridge breaks up collision domains but all the hosts connected to both hubs are still crammed into the same broadcast domain. We are talking about these hosts. That bridge also created only 3 collision domains, one for each port, which means that each device connected to a hub is in the same collision domain as every other device connected to that same hub. This is really lame and to be avoided if possible, but it's still better than having one collision domain for all hosts. The 3 interconnected hubs, we are talking about these, the 3 interconnected hubs at the bottom of a figure also connect to the router. Okay, this setup creates one collision domain and one broadcast domain, and makes that bridge network within its 2 collision domains look majorly better by contrast. The best network connected to the router is the LAN switch network on the left. Why? Because each port on that switch breaks up collision domains, but it is not all good. All devices are still in the same broadcast domain. And if your broadcast domains are too large, the users have less bandwidth and are required to process more broadcasts. तो यहाँ पे आपने देखा, ठीक है, 3 किस्म के आपको वो दिखाए गए हैं. जो सबसे बेहतरीन है वो ये स्विच वाला है, ठीक है, लेकिन स्टिल वो भी इसके साथ जितने भी कनेक्टेड यूजर्स हैं वो सेम ब्रॉडकास्ट डोमेन में है, लेकिन उनकी कोलिजन डोमेन जो है वो अलग अलग है. याद रखिएगा, स्विच कोलिजन डोमेन को ब्रेक करता है, जितने नंबर ऑफ कनेक्शन होंगे उतने नंबर ऑफ ब्रॉडकास्ट सॉरी कोलिजन डोमेन होंगे. यानी इसकी कोलिजन डोमेन एक ये है, 2, 3, इस तरीके से ये 4 और ये 5. यहाँ पे आप देखें तो ये सिंगल कोलिजन डोमेन है, तो ये 5 और एक 6 हो गए. और यहाँ पे आप देख सकते हैं कि ये 2 है, एक ये है और एक ये है, ठीक है, तो ये कितने हो गए, 7 हो गए. और ब्रॉडकास्ट डोमेन कितने हैं, क्योंकि सिर्फ राउटर ही ब्रॉडकास्ट डोमेन को डिवाइड करता है, तो जितने नंबर ऑफ कनेक्शन ब्रॉडकास्ट और उसके राउटर के होंगे उतने नंबर ऑफ ब्रॉडकास्ट डोमेन होंगे. तो ये 1, 2, 3. अच्छा, don't misunderstand, bridging switches are used to segment networks, but they will not isolate broadcast or multicast packets. It is important to keep your broadcast domain small in the vast majority of networks today. Here I have placed the LAN switches at the center of this network world, with the routers connecting to the logical networks. If I went ahead and implemented this design, I have created something called virtual LANs, RVLANs, which are used when you logically break up broadcast domains in a layer 2 switch network. It's really important to understand that even in a switch network environment, you still need a router to provide communication between virtual LANs. Don't forget that. You can see a real world scenario over here, asking whether I should replace my existing 10 over 100 Mbps switches or not. ठीक है, आप इसको पढ़ सकते हैं. यानी लाइक सपोज आप नेटवर्क एडमिनिस्ट्रेटर हैं और आप एक इदारे को ज्वाइन कर लेते हैं या स्टिल एग्जिस्टिंग इदारे में हैं, आपको फील होता है कि जो स्विचेस लगे हुए हैं उनकी स्पीड कम है, आउटडेटेड है, काफ़ी टाइम हो गया है, तो क्या आपको उसको सबको रिप्लेस करना चाहिए या नहीं. तो एक तो इसमें ये चीज़ आ जाती है कि बिल्कुल जैसे विद द पैसेज ऑफ टाइम जितने भी नए प्रोडक्ट्स आते हैं, स्विचेस आते हैं, उनकी स्पीड और उनकी जो एफिशिएंसी होती है, फीचर्स होते हैं, वो बढ़ जाते हैं. तो डेफिनेटली आपको नए प्रोडक्ट्स को करना चाहिए, रिक्विजिशन उसकी डालनी चाहिए, लेकिन स्टिल आप ये भी देख सकते हैं कि जो बजट का इशू होता है वो हर जगह ही होता है. तो ऐसा नहीं होता कि बजट अनलिमिटेड सबके पास होता है. तो उस केस में ये हो सकता है कि आप अगर क्लेवरली प्लान कर लेते हैं अपने नेटवर्क को, तो भी आप अपने ऑब्जेक्टिव्स गेन कर सकते हैं. लास्ट क्वेश्चन जो है वो ये है कि आप अपने स्विच के जो पोर्ट्स हैं तो तमाम के लिए 1 गीगाबिट्स पर सेकंड की स्पीड रखना चाहेंगे, चाहे वो यूज़र है, सर्वर है या दूसरे डिवाइसेस है। तो अगर हम आज के नेटवर्क्स को देखें जिस तरीके से वो डेटा प्रोसेस कर रहे हैं, फॉरवर्ड कर रहे हैं, तो बिल्कुल हर पोर्ट पे, चाहे वो सर्वर है, यूज़र है या दूसरे डिवाइसेस है, हमें उसके लिए ज़्यादा से ज़्यादा स्पीड दरकार होती है। तो यहाँ तक हमारा पार्ट 3 तक, मिलते हैं पार्ट 4 में। थैंक यू।